Hey everyone, I have gotten some questions on the graphing problems from section 6.4. So I wanted to take a couple minutes and go through a couple of the graphs just so really you can see how to use the graphing features in the Pearson product and answer some questions that you may have. So this is my iteration of homework problems 6.4, and it seems that most people are not having trouble with the first 11 problems. So it starts with the graphing section in problem number 12. So this is my version of problem 12, and it says to graph the function y is equal to 6 sine of x. So if we're going through this particular function, we're dealing with 6 sine of x. So our amplitude here is equal to 6. Remember, if it's negative, that amplitude is still equal to 6. The difference is that the amplitude is really the absolute value, or the distance between that midline and the top or bottom point. Now, if I'm going to graph it, this does not have an alteration in the period. So if it has an alteration in the period, it would reside right here. So the period is equal to 2 pi over omega, but omega is 1 here, so our period is the basic 2 pi. Now remember the sine function, basic graph of the sine is the one that goes through the origin, goes up, goes down, and back, and so forth. So this is our basic sine function. All right, now the graphing tool itself, I'm going to use the click to enlarge arrow, and then what I'm going to do is move into this graphing tool. So I have to choose whether I'm graphing sine or cosine. So it has the sine tool and it has the cosine tool. So that's what I want to do, is I want to work on the sine tool here, and then I'm putting in points for my first point here. Now this one does not have an adjusted period, so it's going through the origin. Once I click into that graph, then I get to adjust the period and the amplitude. It brings up a little palette. So this one has an amplitude of 6. So I'm just going and deleting that one and putting in a 6. So it's already adjusted my graph with that amplitude. My period is 2 pi, so I'm leaving that alone. If I wanted to put in something else, a common mistake that I've seen is typing 3.14 instead of pi. If I wanted to put in pi, if you type pi in the box, it will change it to the pi symbol, so you can use that. Now we don't have a vertical shift, we don't have a phase shift. Those will come up in section 6.6. Once they do, this is a drag bar. So if you have a phase shift that's say pi, later on you drag it over to the pi. If I'm reflecting about the axes, I can click one of these reflections here as well. So this is what I want, is 6, amplitude of 6. I'm going to save it, and then I can check my answer. All right, moving along, it does want to know what the domain of 6 sine of x is. Well, domain of sine and cosine are both negative infinity to positive infinity. So I have negative infinity and positive infinity, and then closing my parenthesis. My range changes based on your amplitude. So you see from the graph here, if I enlarge it, the graph goes at its lowest value to -6, highest value to +6. So that is my range. Now I'm using a square parenthesis or square bracket because it includes both of those values. Next question, moving on. Similar thing, except we have a reflection here and our period is different. So we have to first find the period. So our next function here, y is equal to sine of -8x. Our amplitude this time is 1. Our period is equal to 2 pi over omega, and in this case our omega is 8. So we have pi over 4 for our period. Now, this particular negative sign in here is a reflection over the y-axis. So this is reflected over the y-axis. If it were reflected over the x-axis, that negative sign would be out in front of the function. All right, so let's do our graph. All right, we're still dealing with sine, so I'm going to click the sine and then click a point so that it brings up my palette. All right, my amplitude is 1 here. Period this time is pi over 4. So I'm typing pi, pi, and then the divided by symbol gives me the fraction and pi over 4. Now this is a reflection about the x-axis, so I also clicked that reflection. Now it was really fast, so let me go and click it and go back. So if I unclick it, you see how it's increasing from 0 and then decreasing and so on. If I've clicked this reflection about the x, it's now decreasing, so it flipped it this way. And actually it's supposed to be reflected about the y. It doesn't really make a difference with sine whether it's reflected with x or y. It does the same thing, but this is a y-axis reflection. All right, closing that up. We're going to save it and check it. Domain, same, negative infinity to infinity. And range here, since our amplitude is 1, we're going from -1 to +1. All right, so this problem here is number 14, and it asks us to find the equation of a sine function with an amplitude of 4 and a period of 2 pi. Now, if I'm looking at this, remember that the amplitude is the absolute value of whatever number is in front of our function. So an amplitude of 4 actually could result in one that has -4 in the front and it's reflected, or one that has just plain old 4 in the front. Both times we're working with the sine function. It says to find a sine function. Now as far as the period part, our period, remember, is 2 pi over omega. So it tells us that our period is equal to 2 pi. Since I have the same numerator, this means that I have to have 1 on the bottom for my denominator, for my omega. So we are really dealing with 2 separate functions. One with each one has our omega term here. And since it's 1, it's understood. And one with positive, one with -4. So we have 2 equations. The equation when a is less than 0 is y is equal to negative sine of x, -4 sine of x. And when a is positive, we have 4 sine of x. All right, video question number 15. Number 16 is asking us to write the equation of a graph. So I'm going to enlarge this graph so that we can take a look at it. All right, the first thing that we have to decide is if we are dealing with sine or cosine. So looking at this, remember that if you are dealing with a sine function, the sine function starts at the origin and looks something like this. If we're dealing with a cosine function, then the cosine function starts at its high place and looks like this. So if I'm looking at this graph, this is a cosine function. It's starting at its high place, moving this way. Now here I have y is equal to something, where that's my amplitude, cosine of something times x. So our period part is what's going to determine the omega. Our cosine, our amplitude part is going to be based on the graph. So the amplitude is the easier of the two to tell. I'm really just counting from my midline to the top or midline to the bottom. So here I have 2 units, top and bottom, for my cosine function. Now, if I am looking for omega, I have to figure out where this function is actually recycling. So how big is the period itself? Now notice that I'm not in units of pi here. So remember that your period is equal to 2 pi divided by omega. Now it looks to me, based on this graph, that I'm starting at 0, so here is my point 0, and I'm hitting my high point again right here. Now if I count those units, 1, 2, 3, 4, 5, 6, 7, looks like I'm hitting it again at 7. So 2 pi over omega is equal to 7 here. Now I need to solve for omega, so 2 pi divided by omega is equal to 7. Multiplying by omega, 2 pi is equal to 7 omega, and then dividing through by 7 to get omega by itself, 2 pi over 7 is equal to omega. Now that's what I'm going to put in here, 2 pi divided by 7, and I'm going to type that in as my answer. So we have 2 times cosine of 2 pi divided by 7 times x, and closing that. All right, this is going to be similar, so use the same kind of strategy for this one. And this is guided visualization. If you have any further questions, please let me know. Some of these are kind of trial and error until you figure out how to use the graphing tool, but if you'd like to meet, I'm happy to meet. Have a great day.